Welcome back to another training session in OpenDSS-G. Today we're going to talk about a new module introduced into DSS-G that is called the Fault Manager. In the past, faults used to be applied almost directly into the model, but they were not giving too many options of all the set of options available with OpenDSS. In this case, we wanted to change that. So for that, I'm bringing the IEEE 123 bus system, and in simulation mode, I'm calling the Fault Manager. Now it has several options. I can save multiple faults. I can introduce new faults. I can apply one or multiple faults. I can disable one or multiple faults. I can see all the properties, the help, etc. So for this exercise, what we're going to try to do is create a fault, see how it looks like, and well, try to play with it a little bit around. So when I create a new fault, the system is going to assign a name automatically. In this case, I'm going to change it just a little bit to show that it can be changed. The first parameter that we want to modify is probably the number of phases, defining the number of phases that we want to use for this fault. Another feature that we have is, as we've been doing so far with all the different objects within DSS-G, is to provide help, dynamic help that can be acquired at any time when editing an element. So as I mentioned before, first we're going to set the phases. In this case, it can be a three-phase fault. And then we're going to define the first bus. The first bus can be defined in two ways. One is by double-clicking on it and selecting the name of the bus I want to connect to. So in this case, I'm going to try with bus 97, which is part of the list. I can locate it just to make sure, and then I define how the things are connected to it. Once I do that, bus 2 is going to be automatically populated, forcing a delta-like connection. I can change that just by clicking in bus 2. Another way of defining bus 1 is right-clicking and selecting it from the GUI. So in this case, I'm going to change the bus and I'm going to go for 101. And with that, I've selected everything. You can see that bus 2 has been updated automatically, of course, keeping the delta configuration. If I want to change that, again, just double click on it. And let's suppose right now the connection sequence is 1, 2, 2, 3, and 3, 1. I want to do it backwards. So I'm just going to say, okay, let's do 1, 2, 3. And C to 2 and B to 1. And that way it's going to alter the connection sequence. Very interesting. Another feature I can explore is with the bus options, force everything to be face-to-face connected or face-to-ground. In this case, with that option, bus 2 gets automatically updated to reflect a line-to-ground fault. Right now, I'm going to leave it just as it is. Again, I can ask for help anytime I need. Also, I can see the fault on the GUI dynamically, etc. So now we have our first fault. I can close the tree if I don't want to see more, and I'm going to create another fault. In this case, I'm going to modify the name as well, and very quickly, I'm going to define the number of phases and etc. So first, number of phases, another three-phase fault, and I'm going to go for bus 1. I'm going to select it from the GUI, which is very easy. So in this case, I'm going to apply on bus 21, connect everything, and it's going to be a fault line to ground. I'm going to force everything line to ground. And with that, we're ready. So now I'm going to play in snap mode, applying the faults independently, and then all of them at the same time. But to make sure we have everything enabled, I'm going to make it visible, and I'm going to change the color from blue to red to make it visible. So every time it's enabled, we should be able to see it. So we just solved the system. We're going to see the power heat map that we have here. I'm going to make the number of phases thicker so we can see better. And I'm going to apply this fault. We can see that it showed up. So the next time I solve, well, it's asking that as well as complaining about the maximum control iterations. So I'm going to change that on the configuration menu. Just go from 22 to 100, just for the sake of the example. And then, boom, it's solved. We can see with the voltage heat map that everything went blue, which means we got 0 voltage because of the fault. And once I remove the fault using the icon on the top or the pop-up menu, well, it will take effect. Now I'm activating the other fault. I can remove it, solve, and we'll see the effect immediately. Now I can apply all the faults at the same time and see what's going on. We can see that both are active and well, damage on the system is the same. We can disable them at the same time, etc. Yeah, we can play with the different heat maps to see the impact, like what happens when I activate the first one. Well, of course, most of the power is going directly to the fault. If I change to overloaded lines, well, that will basically display a path to the fault, which is very interesting. And also, if I activate both of them at the same time, uh, both faults, probably we're going to see that all the lines around those faults or directing to those faults are gonna be overloaded. Well, this is very graphical, and the idea with this manager is to make it easy. Now, you may ask, what happens with what we used to do in the past, playing like with a real-time simulation module and figuring out, applying those dynamically? Can I do that? Can I do the same thing? Yes, you can. So right now I'm trying to figure out how to change the mode. Here's the mode. I'm gonna change it to time mode. I'm gonna make the step size to 1 second. The units is 1 second, so it's going to be 1 second. And right now we're going to leave the control mode static for the sake of the example. So now we're going to click home, close the configuration menu, open the auto advance simulation. It's going to be doing the auto advance every second, and we're just going to start playing. So we can see that the simulation is advancing by itself every second. And with that, we're going to apply these faults one by one. So I can play here, boom, the simulation responds automatically every second. I can just remove it. There are other examples in which we can see the effect of reclosers and protection devices while running the simulation, and even the regulators. Actually, I'm going to try to do that here. I'm going to change the control mode from static to time. That way we're going to be able to see the regulators changing dynamically. Well, slowly, but we'll see those changes. So again, I'll try to apply the fault, wait a little bit, try to bring the system back, and then, well, we should see some changes in terms of the voltages, the heat map that we are displaying right now. Now, what if while I'm running the simulation, I would like to create a new fault? I can do it just as we did offline. Just create a new fault, assign the name. You see the simulation is running at the same time. We're gonna select bus 1. This is gonna be like a single phase fault. So I'm gonna select the bus right here. We're gonna send it to bus 2, to terminal 2. It's just gonna be one phase. By default, it takes one. Well, it's gonna be face to face, and we apply that, and we can see the response when it happens. So the next time I clear, the rest of control devices will try to respond to this situation, to this event, and try to normalize the system operation. Also, I can try by applying all the different faults that I've created at the same time and see what happens. So depending on the configuration of your system, you're going to have a different response. And probably this new way of managing faults is going to be very interesting for the project you're trying to develop.